All right, everybody. And so this is the review session for EGME 441, Engineering Biomechanics for the fall 2021 semester for midterm 1. Okay, and so I looked at the poll results on Canvas, and I saw that the two winners and they were perfectly tied with each other, are going to be bone biomechanics and muscle biomechanics. Okay. And so I'm actually glad, I think these were, I think the two most, at least in terms of new stuff that we covered, these are the two new things that we learned. And I think they'll make great topics for this review session. Okay. And so just to kind of remind you, remember the format for the midterm exam is going to be all conceptual questions, right? And so we haven't really done anything that requires any significant calculations yet. And I'd rather you come away from this first unit of the class having a good grasp of all the concepts, because we're going to be building on a lot of these concepts going forward once we start to go through the different parts of the body. Okay? And so it's really important to me that you have a good conceptual understanding of what bones are, how they behave, what muscles are, how they behave, what their roles are, so that we can go do this going forward. Okay. All right, and so the way I'm going to structure this review session, because these two topics kind of got the equal amounts of votes, is that I'm going to spend about equal amounts of time on both of them. And I'm going to structure this review session, in a way that I usually suggest people how to study. And so, I've also given you guys the study guide, with which you can use to study. And what I'm going to do is I'm going to run through, all the different learning objectives in the study guide, and then talk about how I would answer these questions, right? And so, I format these learning objectives specifically, to sound like, a question that you would get on an exam that you can use to test your knowledge, right? And so I think the best way to study these conceptual learning objectives is to take the learning objectives and try to answer the question or try to do the thing that it tells you to do, right? And if you feel like that you can do it and you give a confident answer in that, then that's a great way to kind of prepare yourself for the exam, right? Because first of all, I think it gives you a kind of a purpose mindset on which you're approaching the notes, right? And so when you're approaching the textbook or you're approaching the notes, you're kind of doing it with the purpose of, let me find the answer to this question. And I think that's a much more effective way to study. And I think it gives you practice just kind of formulating your answers, in a way that would be beneficial on the exam, okay? Okay. And so let's go ahead and start. Okay. And so let's start with bones. Okay. And so the first learning objective that we have for bones is, to describe the role that bones play in the body. Okay. And so just, very simply, what do the bones do for your body? Okay. And so, your bones, they kind of serve two, at least to me, they serve two very important roles for the human body, right? And so first and foremost, as I think probably the most rigid and strong structures within your body, then one of the main roles that bones play is they provide the rigid framework that supports and protects the soft tissues in the body. Okay. Okay. Right. And so they are literally, the backbone of your body, right? And so, think about the pillars that support a building, right? And so these are the parts of the building that sustain the most stresses, okay? They sustain the most loads. And it's the same thing for the skeleton, right? And so for the bones, because they're so strong, they're going to be sustaining most of the loads, right? And so, typically, for a normal human, this is going to be gravitational loads, right? And so just standing up, sitting down, your body's going to sustain those loads from gravity. Okay. But when you're doing other stuff too, so like maybe when you're exercising, or maybe when you're, you're lifting a lot of weights, right? Then your skeleton is going to provide basically the structure and the rigidity in order to perform those actions. Okay. All right, and so that's the first main role. Okay, the second main role that bones play, I would say, is they basically let you move stuff, right? And so their rigid nature basically allows muscles to attach to them, and then this allows you to kind of use your muscles to manipulate your body and to perform actions. Okay. Okay, and so to sum it up, we can say it forms a rigid system of levers. Okay, that can be moved by forces from attaching muscles. Okay. All right, and so I would say, those are the two main roles of the body. So one, provides the structural support for your body in order for it to sustain loads, and two, it allows you to actually, do stuff, right? Because if you can imagine that if your body was just made of jello, or if it was made of pudding, it'd be really hard to actually, pick stuff up, right? And so you wouldn't have any rigidity to actually, pick stuff up. Where you couldn't perform any actions, right? And so that's kind of another, I would say, underrated part of your body. Okay. All right, so that's the first learning objective. Okay, so number 2 is to describe the material composition of bones. Okay. All right, and so to sum this up, basically, bones are made of some hard minerals. Okay, hard minerals and collagen and water. Okay. And so let's talk a little bit more about the hard minerals. Okay, so the hard minerals are things like all the calciums, right? And so things like calcium carbonate, calcium phosphate. Okay. Right, and so it's these materials that give your bone, the strength and the rigidity that it has. Okay, so these are the strength building components. Okay, whereas the collagen and the water, okay, both of these kind of perform the same thing. All right, and so these kind of help contribute to a little bit of flexibility, and also helps it have some tensile strength. Okay. Okay. Because remember what these are. So remember, collagen is this kind of stretchy kind of material that's used in your body in a lot of different tissues, right? Not so much in bone, but it's used a lot in like your blood vessels or in a lot of your other soft tissue, right? And so it's a very kind of flexible, stretchy material. And so the fact that bone has some of these gives it that flexible nature, right? And water is water, right? And so water is going to contribute some weight and also a little bit to stress, but all strength. I'm sorry, but it also helps it be a little bit more flexible. Okay, and this flexibility is important, right? Because you don't want your bones to be too brittle, because your bones sustain such a wide variety of different loads, right? Some of those loads are very impulsive in nature, right? And so you might have really strong impacts, right? And so if your bone was just made of these, very hard minerals, yes, it would have a lot of strength, but it would also be extremely brittle too, right? And so whenever you have like a very high impact load on it, right, your bone might sustain a very high amount of stress in a very short amount of time, right? And so for brittle materials, that might be very easy. It might be very easy to cause a fracture in those cases. But if you have some flexibility, then the bone can actually bend a little bit, right, and deform a little bit before it actually does, any kind of real injury, right? And so that flexibility, even though a lot of people don't think of bones as flexible structures, that little bit of flexibility is key because of, the nature of the loads that it can experience. Okay. All right, and so that's the second learning objective. Okay. 3 is to explain how porosity of the bones affects its material properties. Okay. And so with this learning objective, remember, we talked about how bones are these kind of porous structures, right? And so it's not all just one continuous material. There's actually a lot of little holes or a lot of little pores in them, okay? I don't know if I spelled that right, but whatever. Okay. And these holes actually help contribute to its properties too, right? And so we actually, remember, we talked about 2 different kinds of bones based on its porosity, right? And so first we have a cortical bone. Right? And so these bones have very low porosity. If you want to put a number to it, about 5 to 30% of its volume. Only 5 to 30% of its volume is occupied by non-mineral tissue. Okay. And cortical bones, these are the much stronger ones, right? Because they have a very large volume or percentage volume of their structure be mineralized tissue. That means they're going to have they're going to be much stronger and much stiffer. Okay. All right, so that's cortical bone. And the other type of bone that we have is trabecular bone. Okay. And so trabecular bones, you can kind of think of it as the opposite of cortical bones, right? So these have a very high porosity. Okay. And so in terms of a percentage, these have about 30 to 90% of its volume occupied by non-mineral tissue. Okay. And this makes it almost look like a sponge, okay? Oops. And so these don't have the same strength as the cortical bone, but they are a lot more flexible. Right. And so these have a much better ability to deform and strain compared to cortical bone before it actually fractures, okay? Right. And so, generally what you can, and so to kind of peel back a little bit, right? And so generally what you can say is that the more porous a bone is, the more, flexible and the less strong it's going to be, right? And so, I think these 2 types of bones illustrate that very clearly, right? Cortical bone, not very porous. It has a lot of mineral content, and so it's much stronger and stiffer, but maybe more brittle. But trabecular bone, much more porous and therefore a lot more flexible. and that helps it a lot too. Okay? And so you can mix and match, both of these types of bones within the same, actual real bone, right? And so I think the example that we gave in class was, let's consider a typical long bone, right? And so in a long bone, what you might see is that, near the edges of the bone, right? Near the edge of the bone, you might have trabecular bone, okay? Okay. And the reason for this is that at the ends of the bones, right, this is where the bone is going to interact with other bones at the joints, right? And so the ends of the bones tend to sustain a lot of impacts because you have bones colliding with each other, bones colliding with the soft tissue, right? And so a lot of times when your body itself sustains like a heavy load, then a lot of that gets placed at joints or at the bones of the joints, okay? And so it really helps to have these kind of flexible tips so that they can kind of almost act like shock absorbers a little bit, okay? Whereas most of the strength of the bone is actually going to come from the shaft. Okay? And so in the shaft right here is you have cortical bone, because these are going to be the parts of the bone that actually sustains the load, and that's where it needs its strength. Okay. Okay. All right. And so this is taking a little bit longer than I thought. And so I don't take a lot of time to go through all the learning objectives, but I do want to cover the key ones and then give a good kind of description of those ones. Okay. All right. And so the next one actually is pretty important. Okay. And I think we can cover pretty quickly. And so that's characterize the elastic properties of bones. Okay. And so what I mean by this is that, I want you to characterize how the bone acts as a material, right? If you compare this to like steel, or you might compare it to like aluminum, right? And so how those materials respond to stress, right? I want you to basically describe that bones as well, right? And so for a typical material, for a typical, isotropic linear material, we have this simple kind of stress strain relationship, right? So we say the stress is equal to the Young's modulus multiplied by the strain. Okay. But for bone, bone is a little bit more of a complex material, so we don't have this this relationship. Okay. And the main reason behind that is that bones are much stronger in compression than they are in tension, are much stronger in compression than it is in tension and shear. Okay. And the reason this is because bones are normally expected to sustain compressive loads a lot more often than it is to sustain either shear loads or tensile loads, right? And so if you think about when you stand up from your chair, when you're standing up in general, right? Then gravity is pushing your body down, and then the normal force from the ground is pushing it up. And so there's kind of a net compressive force that's on your body, okay? And so that compressive force gets transmitted to your bones, okay? Especially the bones of your back and of your lower body, okay? And so generally, because of this, because your bones are subjected to so many compressive loads, that they need to be much stronger in compression than they are in tension or shear, okay? And so this simple material model of a linear isotropic Young's modulus type of material is not adequate to describe the the material properties of bone. Okay. All right. And so two other material models that have been proposed in the literature for describing bones. We kind of went over them briefly in the class. Okay. And so one of those material models is called transversely isotropic. Okay. And then the other type of material that we went over was an orthotropic material. Okay. Okay. And so both of these material models have the advantage that you can specify different strengths in different directions. Okay. And so that's going to be a much better upgrade over the linear isotropic material model, that we normally have for, for other materials. Okay. But with that said, even these two material models are not perfect, even though there's been a lot of experiments and a lot of tests done to determine, what are the properties for, for these material models. But even then, they don't capture, bone material properties perfectly, just because it's such a complex material, and it's actually living material too, because you have living cells on the inside. Okay, and so finding the perfect material model for bone is still, believe it or not, still an ongoing area of research, and I think we'll still continue to research that, for the foreseeable future. Okay, all right. And so that's what I mostly wanted you to get from the elastic properties. Of course, I'm skipping over the details of these material models, but I'll leave that to you to study on your own. Okay. And so the next learning objective that I want to go over is the idea of how bones grow and develop over time, and the idea of bone remodeling. Okay, so this is learning objective 6 and 7 from the bone biomechanics section. Okay, and so 6 and 7 kind of go in hand in hand a little bit, because they all kind of encompass this general idea that your bones respond to stresses. Okay. Okay. If you place a load on a bone, if you place some external forces on it, it's going to cause the bone to develop internal forces. Okay. And then the bone cells actually sense these stresses, and then they're gonna grow and develop in different ways according to what they sense. Okay. Okay. All right. And so, just going into some of the specifics, but a lot of what we know about how bones grow and develop is kind of based on this idea, right? So let's go into some of the specifics that we have in the notes, right? And so typically, when we say bones are growing, for adolescents or for kids that are still kind of getting taller and stuff like that, bones will typically grow in the longitudinal direction. Okay. Okay. And all that means is that the bones are just going to get longer. Okay. Okay. But with that said, it is possible for bones to get thicker, right? And so that's called circumferential growth. But typically, for most people, and specifically for most kids, your bones are primarily going to grow in the longitudinal direction. Okay. And the location on which it grows is this piece of your bone called the epiphyseal disc. And so if we have a typical long bone, right, at the end of your bone, you have this section here called the epiphyseal disc. Okay. And so this is where basically your bones are going to get long. Okay. So new bone cells are going to be deposited here, and then that's going to contribute to the length of the bone. Okay. All right, and so, like I said, circumferential growth is possible, and this process is most dramatic or most aggressive in adolescence, so before the person becomes an adult. But it is still possible for adults to grow bone mass as well. Okay, right. And the main reason that circumferential growth happens is that, typically as a person ages, then they're going to get, heavier and heavier. Okay, and the circumferential growth is to make sure that, as the weight or as the load of the person increases, then the bone has enough, you can almost think of like girth in order to support all that weight. Okay. Okay. All right. And so, another important point is that typically as people age, your bones will start to lose collagen, and so you'll get more brittle. Okay. And so, for older people, there's always a concern of more of bone fractures happening a lot more easily, just because their bones are a lot more, a lot more brittle. Okay, and so now let's talk about bone remodeling, which I think is a really important topic from this, of this section, right? And so this encompasses learning objective 7. Okay, and so learning objective 7 is a little bit long, and so I'm just going to say that this is the learning objectives where I tell you to learn about bone remodeling. All right. And so like I mentioned on the previous page, your bones are going to respond to stress. Okay. And this idea, it kind of follows from this philosophy of form follows function, right? And so we talked very briefly about Wolff's law in the lecture. And what Wolff's law basically says is that the shapes and the sizes of the different parts of our body, the reason they take those forms is that they're well suited to what their function is or what its role is. Okay. Okay. Right. And so Wolff's law, you can basically sum it as form follows function, and it doesn't just apply to the human body. You can apply it to basically any creature that went through some kind of evolution. Okay. All right. And so the bone remodeling process is kind of the biological process through which the bones adapt themselves to external forces. Okay. And so the strict definition of bone remodeling, right? And so the strict definition is that this is the process through which older damaged bone material is reabsorbed into the bone and newer, stronger bone material is formed to take its place. Okay. Okay. And so this is a very core process that your body undergoes, because that's basically how it strengthens your bone and makes sure your bones are healthy. Okay. Right. Right. And so this remodeling process, this is a direct response to, the stresses that the bone undergoes, right? And so basically the whole kind of process goes is that, maybe you do some exercise, or you maybe just walk from one place to the other, right? Your bones are going to sustain some loads, okay? Those loads are going to produce internal stresses within your bone. And then those stresses are going to trigger this remodeling process, okay? And this process is incredibly important for your body, because that's basically how it maintains, your bone health, right? And so this is one of the main reasons why, it's important to maintain a regular exercise schedule, right? Because it's not bad to walk and to stand up and to kind of go about your daily life, right? But this doesn't put the intensity of the loads that actually needs that your body needs to really trigger a lot of remodeling. Okay, and so it's highly recommended that you engage in regular exercise, because that's what's going to stimulate this remodeling and maintain the health of your bones. Okay. Not healthy, active. Right. And certain exercises are going to be a lot better for triggering bone remodeling as well, right? And so typically you want to do some high intensity exercises, and so exercises like jogging or maybe light cardio, that's not going to be as effective as like heavy weightlifting or any kind of explosive exercise. Okay, and so if prioritizing if bone health is a priority for you, you want to make sure that you do these high intensity activities. And so you place high impact loads on your bones, okay? Right. And in the absence of any loads at all, then your bones will actually start to atrophy, right? And so we talk about atrophy as a process through which your bone actually starts to lose mechanical strength because this remodeling isn't triggered, right? And so these older and damaged, bone cells, they'll be absorbed by your body, by your bones, but they won't be replaced by new cells because your body feels like it doesn't need it. Okay, and so we talked about a very interesting instance of when astronauts go to space and they suddenly don't feel the force of gravity on their body anymore. This can actually lead them to to have a lot of bone degeneration, right? Because their body is not experiencing the stresses that it needs for bone remodeling, and their bones just naturally get weaker. Okay, and so for astronauts that don't experience gravity, bone health is a major concern. Okay, all right, and so that's I would say kind of the most important learning objectives from bones. And so we're about halfway through the review session, and so I want to make sure that I cover a good amount of muscle biomechanics too. So let's go ahead and move on to that. Okay. Right. And so just like I did for the bones, the way I'm going to do this is I'm going to look at the study guide. I have that on this monitor right here. And I'm going to run through the learning objectives and then discuss, what I think are the most important learning objectives for you to know for the exam. Okay. But that's not to say that, you should go through all the learning objectives. Well, what I'm doing here is I'm kind of modeling what I feel like is a very efficient and very effective way to study, for this exam. Okay. All right, so we'll start with learning objective number 1. So learning objective number 1 is to describe the role muscles play in the human body. Okay. All right. And so in the human body, muscles have a very unique property in that they're the only, type of tissue in your body that can develop force. Okay. right? And then the only force that it can do is that, we know that muscles can only contract, right? And so the type of force that they generate is tension. Okay. All right. And so this is a very valuable asset. And that's why muscles are, just like bones, one of the most important types of tissues that you have in the body. Okay. Because muscles are capable of generating force, these are the main tissues that you're going to use to produce movement. Okay. Right. And so I would say that movement is the main goal or main role for muscles. Okay, but they also serve a lot of auxiliary purposes as well, right? Because they also help because they're able to develop force. And when you're talking about skeletal muscles, these are relatively controlled by the person. Okay, they also help to provide a lot of stability and a lot of balance to the body as well. Okay. Okay. All right, and so the idea of and so muscles are basically the things that are generating force that helps you stand up straight without toppling over. Okay, all right, and so the next learning objective, and I'd say this is kind of one of the big ones for muscles, is to describe the behavioral and material properties of muscle. Right. And so, what these are is these help to characterize muscle as a material, as a tissue, and how it actually performs. Okay. And so I'm going to spend quite a bit of time on this one because a lot of what we talk about muscles kind of builds off of what we discuss here. Okay. Okay. And so there's I would say four behavioral properties that we went over in the class. Okay. And the first two go together. And so the first one is extensibility. Okay. And so extensibility refers to the ability for the muscle to stretch or increase in length. Okay. Okay. All right, and so that's really important because your muscles are a lot more flexible than bones. Okay, and so the ability to be stretched or increase in length is a very core property that bones have. Okay, all right, and so going along with that, so it's one thing to be able to stretch and increase in length, but the other important property for muscles to have is that after you increase it past its original length, it can then return back to its normal length. Okay, and so that property is called elasticity. Okay, and so elasticity refers to the ability to return to normal length after being stretched. Okay. And so basically what that means that let's say that you have a muscle that looks like this. Okay. Right. So this is like a typical muscle. And if you stretch it, okay, and so let's say that, you, of course, is not to scale, but, you can see that the muscle gets thinner when you stretch it, okay? And so if you stretch a muscle on its own, right, and so that's property one right here of the ability to increase in length, right? Then if you do that, then by itself, without the muscle itself having to attract any force, there's going to be a natural restoring force that tries to bring the muscle back to its original length. Okay. Okay. And so, in other words, there's always this kind of passive force within within the muscle that's purely just from its elastic properties, right? And so this elasticity, this is something that we expect from any elastic solid, right? And so any kind of material that that's used for structures, right? We all consider them to be elastic because whenever we deform it, past its or away from its natural resting configuration, then we know that there's going to be some internal forces within the structure that try to return it back to its original length. Okay. And so this works both ways. And so, here we're talking specifically about, pulling it, increasing it in length, and then for it to return and for it to apply a tensile force to come back. But for elastic solids, we expect it to go the other way too. And so if we compress a material, then there's going to be an outward, elastic force that pushes it back to its initial length too. Okay. Right. And so this is really important because, normally when we think of muscles, we think of the muscles themselves having to actually produce or generate their force, right? But even without the muscle having to do anything, there's actually some forces that get generated within the muscle that can help with muscle contraction, right? And so there's kind of, you can almost think of it as like a passive component to the force and an active component to the force that a muscle can provide, okay? And so we can summarize that in terms of, this circuit, this circuit-ish diagram that we have on over here. Okay. Okay. All right. And so on one side of the circuit, we have maybe one limb in your body, and on the other side of the muscle, we have another limb. Okay. And in the middle, we have these three components, right? And so let's start with the easiest one here. And so let's start with the contractile one, right? And so this contractile component represents the fact that the muscle itself can, produce a tensile force and actually contract the muscle. And so I would say this is like the active component of muscle contraction or active component of muscle force. Okay. Okay. And so this is the part that you actually actively control. So when you contract the muscle, what you're doing is you're tensing up this contractile component. Okay. Right. And then outside of that, you have these two components right here. Okay. The PEC and the SEC, which I'll define in a second. Okay. And I'd say these are the passive components inside your muscle that can also produce force, but these are not the ones that you actually control with your brain. Okay. Right. And so these two, there's two of them because they kind of have separate poles, but these come directly from the elasticity behavior that I talked about on the previous page. Okay. Right. And so, there's, in other words, what I want to, the point I want to make here is that there's more than one source for the force that your muscles can produce. Okay. And so let's talk about what these two components are. Right. And so the PEC, this stands for the parallel elastic component. And what this does is that this provides a kind of like a resistive force. Okay. And the reason I call it a resistive force is that, as you're increasing the length of your muscle, as you're lengthening it, there's a force that's trying to impede this, that's strictly trying to impede this process, right? Because even though your muscle, it's flexible, so you can stretch it, it generally doesn't want to do that because it wants to kind of maintain its resting length, right? And so as you stretch a muscle, this PEC right here is going to provide some resistance to that to try to resist this stretching motion, okay? And so it's not, and so this part, has less to do with, enhancing muscle force. And so this PEC just kind of tries to prevent you from stretching the muscle in the first place. Okay. Okay. Oops. All right, so now we have the SEC, okay? And so the SEC stands for the series elastic component. Okay. And so the series elastic component, you can almost think of it like a spring, right? And so as you stretch your muscle, as the muscle is stretched, the energy that you use to stretch the muscle, that's kind of stored as like a potential energy inside the spring, right? And so when the muscle finally contracts, then that potential energy is released, and then you can have this kind of elastic force enhance the muscle contraction. Okay. Right. Okay. Right. And so what this basically is telling us is that, if we want to create the maximum amount of muscle force as possible, right, then we need to maximize both the contractile component and also this SEC. Okay. And so the contractile component, you can enhance that by working out and growing your muscles and strengthening your fibers. Okay. But there's a lot of things you can do with the SEC to enhance muscle force as well, right? And so the example that we did in class was that, whenever you want to enhance a certain action, the best thing to do, or one of the best things you can do, is actually to stretch that muscle first, right? And then, by stretching that muscle, you get the SEC to basically enhance whatever force that you want to generate. Okay. All right. And so, I think the example that we gave in class was, let's say that you want to jump really, really high. And so that the muscle that mostly provides this is going to be your quadriceps and your calves, right? And so if you want to jump really high, what most people do is that they crouch down first. And so by crouching down, you naturally stretch your quadricep muscles and your calf muscles. And so when you finally release that and jump, then, your muscle force is going to be enhanced from that. Okay. And so this is a very important topic for muscles, and I think it kind of drives a lot of the discussion that we have, later on. Okay. Okay. And so those are the first two properties for muscle. Okay. The next two have to do with, I would say, muscle control. Okay. All right, and so the third important property is irritability. Okay. And so irritability corresponds to the muscle's ability to respond to stimulus. Right, and so your muscle has to be able to respond to stuff, right? And so, whenever your brain tells your muscle to contract, then it should do that, okay? But there's also some non-nerve, stimuli that can irritate muscles as well, right? And so, I think in class we talked about kind of the elbow or the knee jerk test, right? And so you bump the knee, and then it can kind of go up just like that, right? And so in order for a muscle to be useful, it has to be able to respond to these stimuli so that your body can actually control what your muscles do, right? It doesn't do any good for your body to have these muscles if you can't control them, right? Okay. All right, and then the last property here, and so we talked about a lot of the passive, the passive properties of muscle and also its ability to respond to stimulus, but the hallmark of muscles and what makes them different from all other tissues is their ability to develop tension on their own. Okay. Right, and so this refers to the muscle's ability to generate tensile forces within its member, which is of course unique to muscles. Okay. All right. And so we spent quite a bit of time talking about that learning objective, but I think it's one of the most important ones for this, for this chapter here. Okay. All right. And so next, I'm going to skip ahead a little bit because I think we covered quite a few important terms later on. Okay. And so the next learning objective that I want to go over is objective 6, which is to define concentric, isometric, and eccentric muscle contraction. And so I'm choosing to do this one too because a lot of the other ideas that we cover later on in the unit kind of build off these terms here. So I want to make sure that we cover them in the review session. Okay, even though we're not going to have time to cover everything else. Okay. All right. And so, these basically describe, the different types of motion that can occur, at a muscle when it contracts, right? Because we know that a muscle can develop tension, it can develop force on its own, right? But what kind of motion that actually results from this force, it depends on the other opposing forces, right? And so when you're defining these concentric, isometric, and eccentric muscle contractions, we have to kind of distinguish between two actors or two subjects here, right? And so on the one hand, we have the primary muscle force, right? Because when we're talking about these terms right here, concentric, isometric, eccentric contraction, what we're referring to is we have a subject of these terms, right? And the subject is the muscle that we're talking about, right? And so these terms kind of go hand in hand with the particular muscle. And so when we say that the biceps is contracting concentrically, then that's going to be our primary muscle force. Okay. And so there should only be one primary muscle force that we're talking about because that's the one that we're describing with these terms. Okay. Okay. And then the other category of forces that we're going to look at is everything else, basically, right? And so whenever your muscle is supporting a weight, or maybe there's an antagonist muscle on the other side that's producing an opposite motion, okay? All of these are considered opposing forces because they want to oppose the force that the primary muscle is exerting, okay? And the way to think about, the way that you kind of differentiate between the two is to always kind of remember that muscles, even though they can develop a force, that force is mostly translated into a moment or a torque around a joint, okay? Okay. And so the primary muscle force will want to basically develop a torque in one direction, either clockwise or counterclockwise. And then all of the opposing forces will want to produce a torque in the opposite direction. Okay. And so one of it's going to do counterclockwise or counterclockwise. The other one's going to do whatever the opposite of that is. Okay. Okay. And so with that out of the way, we're ready to define our terms. Okay. And so first we have concentric muscle contraction. And so in concentric muscle contraction, the primary muscle torque is greater than the opposing torques. Okay. Okay. And what this results in is that this results in limb motion in the same direction as the primary torque. Okay. Okay. And so basically, whenever your muscle succeeds in moving a limb in the direction that it's contracting in, we call that concentric contraction. Okay. All right. And so the next term is isometric contraction. Okay. In isometric contraction, the primary muscle torque and the opposing torques are exactly the same in magnitude. Okay. Okay. And so when those two torques are equal in magnitude, this produces no motion. Okay. Right. And so that's isometric contraction. Okay. So concentric contraction, the primary muscle torque is greater. Isometric, they're equal. Okay. And so just by process of elimination, we can say that eccentric muscle contraction is when the opposing torques are actually greater than the primary torque. Okay. Okay. And so what this this is a very unique case because when the muscle is contracting eccentrically, then instead of the one actually causing the motion, it's instead acting to kind of slow down or control the motion. Okay. Okay. And this is really important because, you know, a lot of the muscles in your body actually act to, you know, control these sort of things, right? And so, you know, actually, you know, for a lot of, I would say, basic motions in your body, it's actually a combination of some muscles acting concentrically, but then the opposing muscles also acting eccentrically as well to kind of control it, right? And so that's what kind of gives you the very fine precision that you can make with a lot of the actions that your body does. Okay. Okay, and so unfortunately, that's all I have time for because I do have to do something else after this. Okay, but hopefully that review session is useful. If anything, just to kind of model the process through which you can study yourself. Okay, and so really use that study guide and then really go through each and every of the learning objectives and try to answer them for yourself. Okay, I personally think this is the most effective and efficient way to study because then you're really getting at what are all the important topics that I want you to learn for this unit. Okay, and so if you can go through the study guide and cover all of the learning objectives, then you are going to be in great shape for the exam. Okay. All right. So best of luck with your studying, everyone. If you have any other questions on any of the topics that we covered here, or just topics for the midterm in general, feel free to shoot me an email. Right, and then I'll see you guys next week.